Hello, my lovelies. Today I'm going to present to you this math problem, this lovely math problem. Consider the following function f of t whose graph is as shown below. It is given that the Fourier series of the function is f of t is equal to 1/4 minus t over pi squared, the summation when n is odd of cosine of n pi t over n squared plus 1 over pi times the summation from n equals 1 to infinity of negative 1 to the power of n plus 1 times sine n pi t over n, all over n. And which of the following is true? So to start this problem, we probably have to come up with some generic formula or expression for f of t, and that's exactly what we are going to do first. Let me choose a color that I like. I don't like red anymore. I'm going to choose maybe, let's say I'm in the mood for a little purple today. So we can begin by annotating. So f of t is equal to, as we observe from the graph, 0 at some points and t at other points. And the domain at which it is equal to 0 is, as we observe from this portion of the graph, from t is less than negative 1 is greater than negative 1 is less than 0. And t is greater than 0 and less than 1 for f of t is equal to t. And this will be useful for us in solving this equation because essentially what we have to do is we have to pick our t values over here wisely so that certain terms disappear and we get a nice expression for f of t. Critical to observe also is that the graph over here is continuous at 0. Although we have two different functions, it's not always the case that the function is continuous at this point when it's piecewise like this, because we can have a horizontal line here and kind of like a jump over here where the f values for these 2 points are different. But here, the f value at the point 0 is continuous, is the same, even though it's a piecewise function. So that is very nice because of that information, we can choose t to be equal to 0. And when t is equal to 0, f of t is equal to 0 because t is equal to 0 and we have the 0 function. So it's equal to 0 overall. So we can thus say that taking f of t equals 0, we have 0 is equal to 1 over 4 minus 2 over pi summation when n is odd of cosine n pi times 0 over n squared plus 1 over pi times the summation from n equals 1 to infinity of negative 1 to the power of n plus 1 sine n pi times 0 over n. Now, certain terms disappear because sine n pi 0 is equal to sine of 0 for all n, and sine of 0 is equal to 0. So this whole term goes to 0. And actually, I'm going to use another color here to demonstrate the disappearance to 0. And cosine n pi times 0 over n squared. Cosine n pi times 0 is basically cosine of 0, and cosine of 0 is equal to 1 for all n. So this one goes to 1 over n squared. So essentially, we're only looking at 0 is equal to 1 over 4 minus 2 over pi summation when n is odd of 1 over n squared plus 0. And we can subtract 1/4 from both sides to get negative 1/4 is equal to negative 2 over pi um negative 2 over pi Oh, sorry, I missed the pi squared. It's actually pi squared as we see over here, so we can simply add the pi squared right now. Um, Summation when n is odd of 1 over n squared. Um, and now we can divide both sides by negative 2 over pi squared, which will give us negative 1/4 over negative 2 over pi squared is equal to uh, pi squared over 8, which is subsequently equal to the summation when n is odd of 1 over n squared. As we see, this does not really match any of our given options. So we see that we have pi squared over 8 over here, which is the form that we want, and negative pi squared over 8 over here, which is similar to the form we want. We also observed that for the negative pi squared over 8, they have a negative 1 to the power of n instead. Now we can think about what this really means, because notice that the summation of negative 1 to the power of n over n squared is when n is odd, is basically equal to negative 1 times the summation when n is odd of 1 over n squared. Because negative 1 to the power of n when n is odd is always going to be negative 1. Because n is always going to be an odd value. And negative 1 to the power of something odd is always negative 1. So since we know that sigma when n is odd of 1 over n squared is equal to pi squared over 8, we can simply plug in pi squared over 8 here to get that it's equal to negative pi squared over 8. Or more clearly, that sigma for when n is odd of negative 1 to the power of n over n squared is equal to negative pi squared over 8. So thus B is the correct answer. Thank you for watching this video of me, and I'll see you in the next video.